Hello, and welcome to this demo. So this is what we saw in the last demo. We deployed pods and services to keep it really simple. But this setup has its own challenges. Deploying pods doesn't help us scale our application easily. Also, if a pod was to fail, it doesn't come back up or deploy a new pod automatically. We could deploy multiple pods one after the other, but there are easier ways to scale using replica sets and deployments as we discussed in the lectures. Let us now improvise our setup using deployments. We chose deployments over replica sets as deployments automatically create replica sets as required, and it can help us perform rolling updates and rollbacks, etc. Deployments are the way to go. So we add more pods for the front-end applications, voting app, and result app by creating a deployment with 3 replicas. We also encapsulate database and workers in deployments. Let's take a look at that now. Okay, so here I have a new project that I've created in my PyCharm editor, and I call it example voting application -Kubernetes -v2. So I have copied over all the files that I created in the previous demo, and in this demo we're going to modify our setup to convert these pods into deployments. So as you can see, the files that I have are Postgres pod and the service for the Postgres service. Similarly, I have a pod for Redis and the service for Redis, a result app pod, result app service, voting app pod, voting app service, and a worker app pod. Now our goal is to convert all these pods into deployments. The services, we can leave them as is for now. Okay, so I'm going to look up the Kubernetes.io documentation page to pull up the template required to create a deployment. So I'm just going to go to the documentation page and search for deployment and click on deployments. And here I have the template that I need to create a new deployment. So I'm going to go back to my editor, and I will now create a new file for deployment. I will name that redis-deployment.yaml. I will also open the Redis pod definition file that I created earlier in another tab. So on the right I have the Redis pod, and on the left I have the redis deployment.yaml file that I'm going to populate now. I can copy everything from the template up until the template section, and then the template section would be the contents in the Redis pod definition file on the right. So I have the template. I'm now going to rename the deployment from nginx to Redis. I will set only one replica for the Redis because I only need 1 instances of my databases. And then under selector, I will now copy the labels under my Redis pod definition. So I'm going to copy the labels and put them under the match labels section under selector. And then the template section would be everything in the Redis pod section, Redis pod definition file, except for the first 2 lines, which are API version and kind. So I'm going to copy all of that. I will paste it under template, and as you can see, as everything from the second line onwards, that is from the name, line 15 onwards to the bottom, are not aligned properly. So they should be falling under the metadata section, but since I copied it over from the other file, they're not aligned. So I'm just going to select all of that, everything that I pasted from the second line onwards, and then hit tab twice so that they all move under the template section or the metadata section properly. Okay, so I have now aligned it. So I now have my deployment definition file. The name of the deployment is going to be redis-deployment. The number of replicas is going to be 1. The selector matches the labels under the same labels under the template section, and the template section has everything that I created earlier for creating the pod. So I'm now done with my Redis deployment. I don't need the Redis pod definition file anymore, so I'm going to get rid of that. So I've deleted the Redis -pod .yaml file. Now I will repeat the same step for all the other components, which is the next one is DB, which is the Postgres database. So I'm going to open the Postgres -pod .yaml definition file on the right. I will create a new file called pod-deployment postgres-deployment.yaml. Okay, I will now copy over the deployment definition template from the documentation page. I will rename the deployment to Postgres. The app, I'm going to leave the app to demo voting app. I just remembered that I didn't do that for the Redis deployment. So first I'm going to change it here, demo-voting-app, and I'll just also go to the Redis deployment and set the same there. In this setup, we're really not using this label, but it's just good to have all of them tagged with the same label, as they're all part of the same application. Okay, now under the selector section, I'm going to copy over the labels on the Postgres pod. And then I'm going to copy everything from metadata and spec on the right and move it under template section. Okay, so I will paste once, then I'll select everything from line 15 and hit tab twice so they're aligned properly. Okay, so I have the Postgres deployment file definition file ready. I'm now going to get rid of the Postgres pod.yaml file. Okay, next up is the worker pod at the bottom. So I'm going to open up the worker app pod definition file on the right, and I will create a new worker app deployment.yaml file on the left. Again, I will copy a template for deployment. I will set the name to worker-app-deployment. And the app name label is going to be demo voting app. I also need just one replica for the worker. Now under match labels, I'm going to copy the labels from the pod definition file. I will then copy over all the contents of the pod definition under the template section of the deployment. I'm now going to get rid of the worker app pod definition file, as we no longer need that. Okay, now we are left with two pod definition files, which are for the voting app and the result app. We will start with the voting app. So I'm going to open the voting app pod definition file on the right. And on the left, I'm going to create a new file for voting app deployment. I'm going to copy over the template for deployment definition and set the name to voting app deployment. One replica. We will start with one replica for now, and we will update it or scale it up to 3 replicas while it's running. I will copy over the labels and make sure they're aligned properly under match labels. And then copy all the section of metadata and spec, and then align them properly in the voting app deployment file. Okay, we're now set with the voting app deployment.yaml file, and we can now get rid of the voting app pod.yaml file. Alright, and we're only left with the result app. Again, I will open the result app-pod.yaml on the right, and I'm going to create a new file called result app-deployment. We'll now copy the template for deployment, rename it to result-app-deployment, set the app name label to demo voting app. I will leave the replicas to 1 for now, and we will increase the replicas later. I'm going to copy over the labels into the match labels section, and under template I'm going to copy over the metadata and spec section. Okay, and I've made sure that they align properly, and I can now get rid of the resulting app pod.yaml file. Okay, so I'm done with all the changes I need to make. I now have deployments instead of pods, and I have all the services, which I'm okay to work with as it is. The services are directly linked to pods using selectors, so I don't have to make any changes on them. Okay, so I now need to get these files onto my Kubernetes master to deploy them. And so I'm going to first get them on my GitHub. So I'm going to create a new repository on my GitHub account called example voting app-kubernetes-v2. Okay, I will make that as a public repository. And then I'm going to copy the URL to the repository. And in my JetBrains IDE, I'm going to go into VCS tab and enable version control. I will select Git. This will create a Git repository locally on my folder. I can now right click, go to Git, commit directory, and add a commit message called initial commit. So I'm going to commit my repository. I'm going to commit that and push, and here I can define the remote repository URL, which is the URL to my GitHub repository that I just created. Okay, so I have now added a remote origin and pushed the files onto my GitHub repository. So if I now, I will now wait for the push to be successful. So the push is successful. If I now go back to my Git repository, I can now see that all my files are there. So I'm going to copy the URL and then go to my Kubernetes master and clone my repository there. Okay, once it's cloned, I'm going to go into the folder, and I can see all the files that I just created. Great. So all I need to do now is run the kubectl create command -f and with a dot, and it will simply go ahead, pick each file, and create these necessary deployments and services as defined in those files. If I run a kubectl get all command, I can now see that they're in the process of creation. The deployments and services are being created. I'm going to give it some time for it to completely create and deploy the necessary pods. Okay, I can now see that all my deployments, all my pods are in running state. I only have one replicas for all of my deployments, so they're good. And if you look into the services section, you can see that my services are exposed on node port, on port 31061 and 30035. The voting service is on 30035, and the resulting service is on 31061. And I can use any IP address. I can use the IP address of any of my nodes, and along with these ports, I will be able to access the front-end applications. So I'm going to use the IP of one of my nodes, which is 192.168.56.72, and the port 30035, and that takes me to the voting application. I can now cast my vote, and if my voting app is successfully able to reach the Redis service, you will be able to see a check mark indicating that your vote has been accepted. If you look at, if you would like to see the result, again, use the same IP followed by 31061, which is where the result app is exposed. So as and when I change the vote now, I can see the result changing as well. Okay, now if you look at this page, you can see that the vote is processed by container ID, voting app deployment, followed by the ID of the container. Now it's the same right now, even after you refresh the page, because we only have one replica, so it's always going to one pod. What we would like to do now is scale our application. So imagine that the number of users casting their vote or viewing the result have increased. So we would like to modify the number of replicas and scale the application to 3, as you can see in this diagram. All we need to do is modify the deployment definition file. So I'm going to use the VI editor and modify the voting app deployment.yaml file and change the number of replicas to 3. I'm now going to save that, and I'm going to run the command kubectl apply-f followed by the deployment definition file. And as you can see, the deployment has been configured. If I look at the deployments right now, I can see that the desired number of deployments is 3, but we only have 1 available now, so we'll give it some time to spin up the other 2 pods for the voting app. I now have 2, and I now have 3. So I now have 3 pods running for casting the vote. I don't have to make any other changes. The service that we have created for the front-end application automatically picks up the additional pods, and it automatically balances load between them, so we don't have to worry. As you can see, the pod that is serving the application right now is TLS8C. So we're going to try and refresh the page and see if it takes us to the other pods. It's still TLS8C, and now you can see it takes us to the other pod, which is FKJ8F. It's just going between 2 pods right now, but if you keep going at it, you'll see that it ultimately takes you to the 3rd pod as well. So now you can see it keeps going between all the 3 pods. And all you need to do is cast your vote, and your result will be reflected. And each time you cast a vote, it is handled by a new or a different pod. And all of that just works fine. So it's that easy to scale your application once your deployment is configured. Okay, I'm now going to repeat the same for the result app. I'm going to edit the result app deployment file and update the number of replicas to 3. I will now update the change using the kubectl apply command and provide the result app deployment file. When I now run the kubectl get deployments command, you can see that the result app deployment, the desired count is 3, but there's only 1 available right now. And on refreshing, you can see that there are 3 available. So now if I go to go and refresh my result app, it's actually coming back on a new, it's being served from a new pod, but we do not really have the container ID being displayed on this page because it's just not developed that way. So, but you can see the available number of result pods have been scaled up as well. Let us now focus on the front-end applications, the voting app and the result app. We know that these pods are hosted on different nodes. In this case, let's just assume that they're hosted on 4 different nodes. The services with the type currently set to node port help in receiving the traffic on the ports on these nodes and routing and load balancing them to the appropriate pods. But what IP address would you give your end users to access the applications? You could access any of these 2 applications using IP of any of the nodes and the high-end port the service is exposed on. That would be 4 IP and port combination for the voting app and 4 IP and port combination for the result app. But that's not what the end users want. They need a single URL like example-vote.com or example-result.com so that they can access the application by just going to those URLs. Now, one way to achieve this in my current VirtualBox setup is to create a new VM for load balancer purpose and install and configure a suitable load balancer on it like HAProxy or Nginx, etc. The load balancer would then reroute traffic to underlying nodes and then through to the underlying pods to serve the users. Now, setting all of that external load balancing can be a tedious task. However, if I was on a supported cloud platform like Google Cloud, for instance, I could leverage the native load balancer to do that configuration for me. Kubernetes has support for getting that done for us automatically. All you need to do is set the service type for the front-end services to load balancer. Remember, this only works with supported cloud platforms. If you set the type of service to load balancer in an unsupported environment like VirtualBox, then it would simply be considered as if you set it to node port, where the services are exported on a high-end port on the nodes. That would result in the same setup we had earlier. Let us take a look at how we can achieve this on Google Cloud Platform. So I'm now going to go back to my files that I've created in my IDE, and I'm going to update the number of voting app replicas from 1 to 3 so that I don't have to scale it up later. I would like the service to be deployed with 3 replicas to start with, and I will update the number of replicas on the worker app also from 1 to 3. This is just to demonstrate how easy it is to deploy multiple instances in the first deployment itself. I will now make a change to the service types. Earlier I had the service type set to node port, and as we discussed, I'm going to change that to a load balancer type. So I'm going to select the voting app-service.yaml file and change the type to load balancer. Similarly, I'm going to my result app, and I will also change my type of service to a load balancer. I'm now going to commit my changes to my Git repository. I will say update deployments and service type. Okay, so I now have my files committed and pushed to my Git repository. I can now go log into my Google console and try and deploy the same application over there. Okay, now I'm logged into my Google Cloud Console. I'm in the Kubernetes clusters section, and I have one cluster already created and ready for me to deploy my application on. Click on the connect button, and it opens up the connect to the cluster wizard. And here I could simply click on the run in Cloud Shell to open up the Cloud Shell and establish connectivity to my Kubernetes master. Okay, so I just need to hit enter to authorize and get into the Kubernetes master node. Okay, and what I will first do is I will simply download or clone my Git repository. So I'm going to say git clone, then copy the URL of my repository. Okay, so once I have my example voting app version 2 available, I will then create all the files, create all the components needed by simply running the kubectl create-f dot command. This will go in, pick up each file, and create the defined Kubernetes objects. I will wait for some time and give it some time for these objects to be created. I will run the kubectl get all command to see a list of all the objects that are being created. As you can see, it's already created a set of services, deployments, etc. We will first focus on the deployments. So as you can see, it's already created and successfully some of the deployments, and we'll just wait for it to finish all. Okay, so it's deployed a set of services, and I can now access my application using the services. Now when I run the kubectl get services command, in the output you can see there's something new this time, something that we didn't see before, which is the external IP. Now as you can see, the type of service on result service and voting service is set to load balancer, and that has invoked a call to the Google built-in or native load balancer functionality, and it's automatically created an external load balancer, and the IP that you see in the external IP column is the IP of the load balancer that can be used by us or by the external users to access our application. Okay, I'm going to first access the result app. All I need to do is copy the IP, put it in a browser, and you can see the result app. Similarly, I'm going to open up and access the voting service, and that's the voting app. Okay, I'm now going to cast a vote and make sure it's reflected in the result page. Okay, I've now casted a vote, and I can see the result getting updated. And every time you cast a vote, you can see that it's being handled by a different pod, one of the 3 pods that we deployed. Okay, so that's it for this demo. In this demo, we have improvised upon our setup using deployments to create the different components of our application, and we have used services with a type load balancer that internally invokes the native load balancing functionality of the underlying supported cloud platform, and makes it easy to integrate Kubernetes with the load balancers of the cloud platform. So thank you so much for your time, and I will see you in the next section.